Hi, welcome to the Commercial Gas Engineer channel. I was brought to this site in order to diagnose what was wrong with this boiler. When turning it on and checking it, I couldn't find any errors and it had it locked out. And also the manufacturer told me that on this particular model, you couldn't find the previous fault codes, even though it's a pretty modern appliance. So what I did was order up a service kit for it. It was a decent plant room, as you can see here. At another site I went to investigate a boiler that was continuously resetting or continuously going into error. So I was going into the Flamco pressurization unit to just put the code in and check a few things first. Tried to remember the 4706 password for this. It's very helpful. And then the way of testing the pumps. I made a short on this recently. You can see the system there has flagged up an issue because I've jumped into the PU. So I'm hitting the minus button there once I've got into the settings, and that is testing pump 1. If there was another pump, you'd hit the other button here, and then that would test the other pump. You'd hold it down. But now I'm just hitting the set button rather than holding it down to go through the different settings, and then the pressurization unit will be satisfied and tell the BMS to be satisfied. Here we go. System's all fine now. In this particular plant room now, so boiler 2 wasn't happy. It kept basically saying I need to set it up, so it was asking me, do you want me to be a slave or a master? I tried slave mode, but boiler 2, or should I say boiler 1, was not a master, so I couldn't make boiler 2 a slave because it wasn't receiving any instructions from anywhere. So I had to make boiler 2 a master. So here we go, pairing devices. I went through these settings here, setting up the unit, going through the settings. So I have to put all the dates in. I had to do this 2 or 3 times, about 2 or 3 times, and it just kept on resetting again and again and going back to the same thing. I had to keep putting the settings in. And then in the end, got to the bottom of it. What do you think this could be? Any ideas why it just keeps not being satisfied? So this was another attempt of me putting the date and the time in. And then I got this far, advanced configuration. And then I clicked, okay, boiler 2, you're going to be the master. Basic pre-configuration. Then it was doing this loading procedure, loading, and it said it's about to reboot at some point. Then I had to go back, advanced configuration, master boiler. Okay, we've established that. And it starts loading again. In the end, I got the boiler going, and I don't know if you would have figured this out, but the reset button was wedged in. It was stuck in, and it needed to just be pulled out, and then it stopped asking for me to reconfigure it. This is a look inside the BMS panel. You can pause if you like. Those were the MCBs, and then here they are, the MCB labels. And here's the incoming supply. You've got your 3 phases and your neutral. And then the MCBs were labeled. And that's where they are there. And then down here you have the contactors. And then a bit lower you've got some relays. And then your transformer. In the other panel we have more relays. There's quite a lot of them. And they're labeled up quite well. There looks like a relay here. And there was something else. I didn't spot what it was. BMS engineer use only. Okay, so commercial gas engineer cannot use that. Then over here, I don't know the exact name of each one of those little modules there, but I think they're sort of like little add-ons when you can't get any more into the panel. It's sort of like on the DDC controller, I believe. I think these are sort of like your additional. So when you can't get any more of these DDC controllers, I think those are just sort of like add-ons to back them up. Could be wrong there, but that's what I recall it being. The direct digital controller is what we just saw, with your digital inputs and outputs and your analog inputs and outputs. And then here, this is just the back of the display, and here's the front of the display. But you can see this is quite a modern plant room. And then up here we've got a CO detector. Loads of detectors in this plant room, very modern. And then we have a look at the wiring. Pause at any time if you like. I'm just going to give you a brief view of what wiring they have here. This is in the panel. So this all relates to what you just saw in the pictures in the control panel. More drawings. Pause at any time. Universal inputs, first floor space, temperature sensor. I believe I can see they're in and a common. I believe that's what I can see. May have to zoom in. And then here I see 0 to 10 volts and 0 volt connection there on the main controller. Analog outputs. Okay, more analog input here. Forgive me, I'm not a BMS engineer, so I can only elaborate a little bit on this. We've got hot water service, primary flow sensors there. Okay, module 2. Okay, universal input output module. Okay, you can see them there. It's just directed in the panel where these are and the colors and so on. VT circuit. Okay, here we go. Then we've got some numbering of our panel display. Great. And then more here. Excellent. And the boilers. And then the fault. And run and hand and off. Not every panel I've seen, I've noticed a picture of the front of the panel like this, but that's fine. Please feel free to elaborate or discuss things that you know who are viewing. We don't all know the same things, so okay, that was the neutral bar there we saw. And what do we see here? PIR controlled interior lamps. Oh, okay, so that's running through here as well. Wow. Fire alarm activated. Okay, that's there, and they're discussing different relays there. So you're probably going to see the fire safety circuit here. Okay, so what we have here on this page, we've got the relays labeled there, and you can see a relay there of relay 215 and so on. And some of these are showing you the circuits and what will happen when alarms are activated. So this is a bit about this, a bit there is about the heat pumps. This site has got heat pumps, it's got a solar panel. It's a very modern site. There's a pressurization unit there, and it's a safety circuit. Okay, here we have more diagrams. Sometimes on one panel you can learn a significant amount if the drawings are there and they're up-to-date drawings. And if you take your time and go through it, you can learn a lot. On to the next page here. When I find a spare moment, I like to look through the drawings, because sometimes the drawings could go missing, or if you end up in a pickle where you knock off the fire safety circuit, or I mean you hit the knock off button and then you want to trace what's gone wrong when you try and reinstate it, you have an idea of what needs to be on for it to be satisfied. Okay, more wires here. Now solar system, do you see that there? So they've put a solar system in here. There probably wasn't always one. I think that was just a recent thing. Everyone's trying to get more environmental. Got high limit shutdown there. People are trying to strive to do things better for the environment and so on. Things start to get very complicated because not all this is tried and tested in a blend. So a lot of these things are run independently, but then when you see some of these systems run, something kicked in there whilst I was here testing. I think that was the calorifier, and then there was an actuator underneath me also actuating just where I was. Sometimes when you try to connect these systems together, solar, heat pumps, boilers, it does take some wit to get it to all run properly without too much error, and then to repair things when things stop working. I found it quite interesting that the emerging element on this system was running constantly rather than the boiler. The boiler was off, but the emerging element kept running. So I don't see how that would be a saving of electricity. I imagine the boilers would have played some part. Okay, so there's some extra drawing someone's done here on the back. I think these are some updated wiring. Okay, here we go. More drawings here. Pause, please, if you need to. Okay, I believe we're getting to the last few pages here. The pumps and so on. It's good to see which part of these are related to the gas engineer, because not every single bit in the drawings are related to your work. Okay, Let's see if I can give you a little tour of the plant room. So we've seen inside the wiring panel of the BMS panel, and now we are looking around different pumps, Magna, twin pumps, and then clarifier controls. Look at this clarifier around here. Imagine trying to change that element. You'd have to be a very slim and acrobatic man. Flexible too. So there we go. That up there is missing. That isolation valve is off. There's a Magna here. Grumpus pumps are quite popular. Smoke alarm up there. There's another actuator over there on a freeway valve. Which one is this? A Danfoss. So we have heat pumps in this system as well. So we've got two systems here. Not sure what this controller is for. I'm not sure if any of these had to do anything with solar. I know that goes outside and comes in, and then you've got the solenoid there, expansion vessel, another expansion vessel here, dosing pot here, control panel, a view from further back. What else do we have around here? What's this? A Flam Covent Clean Smart. Okay, I've not seen one of these. And then down here we have a different actuator. Blend of actuators in this plant room. Okay, at another job, I'm here checking the resistance on an element. I seem to be doing a lot of elements recently. So have it off and I'm doing a dead test. And I'm getting 64, 65 kilo ohms. I shouldn't be getting these sort of readings, and nor should it be all over the place. It's a 9 kilowatt element. Look at this. I saw an element plugged in like this. I had to shut it off. It was plugged in. This was the element. I don't know what regulation there is for this, but I saw this plugged in and it was just running across the building and not into an isolator or anything like that. I don't know what regulation or where I can find that, whether it's in the wiring regs or what. Maybe you can shout it out. But an element going into a clarifier, I'm sure you can't run it across the room and plug it into a socket in a kitchen or anything of that nature. So this had to stay off. So I was checking for power on it. So do you see the lead? See the lead running up? See it running across the building? There wasn't much light in this building. You see that running around here? Madness. Absolute madness. Look, all the way over there. And I was trying to check with some bad light in the resistance. And yeah, look, there we had our 19 ohms of resistance. So the element was fine. Yeah, the lighting was poor. Typically, they had no light inside here. Wouldn't be surprised if it was tripped by the dodgy electrics. What do you think this is called? So here we have it. This is called something like a side stream filter. I believe it's on the heating system, and I've never come across them before. And the filters needed to be replaced, so I was isolating the unit and looking at them. Look at the steam coming out. That was pretty hot. Side stream filter. Don't know how it works. It's some form of heating filter. This is it from the distance. And this is it. Cygnus side stream filter. What on earth is that? I need to read it up. I think you could sit down and spend a month reading manuals that you need to read at times. Well, it drained out successfully and was put back in situ successfully. So had to disconnect over there. Check out this PRV. How do you think it got like that? Quite a risk if that goes when you're standing in front of it. Another one. Maybe times are hard. People have to cut pipe for copper, but surely that couldn't be the case. Okay, let's do a little tour of this plant room. So it's got some huge clarifiers. CHP. 3 boilers here. Doing some checking on this unit. Don't you love this big hovel? I kind of like it. Especially once I discovered that there was a ladder and I didn't have to climb up it. So yeah, the bottom does pull out and there's a ladder to go on. There have been times in the past where I have climbed up the unit or had to go and get a ladder, not knowing that the bottom comes a ladder. So it helps for you to read manuals before you work on a boiler. So this is behind this particular unit. There's a flue stabilizer there that's open with a flap. That's that PRV I was mentioning to you. This here, I believe, is a strainer, like a gas strainer filter, sort of. And then what else do we have around here? We've got a gas supply. With flues, because there's the serious nature of flues and gas pipes, I always think it's good to put your hands on them and trace them, because sometimes there'll be something you don't see. We've got some pumps here, a bit of corrosion down there on the differential running on the suction and discharge side. There's a bit of corrosion on there. Hopefully that will last. There was a dose input over there, and this is that side stream filter I was telling you about. You can see all that water down the floor because I had it open for a moment and there was no drain point. And then what do we have over here? We have a vessel pressurization unit here, expansion vessel, there's a CHP pump there. Okay, we've got some pumps here. I believe this was like, the pumps were not satisfied. I don't know if you can see it on there. Does it say? Can you see it's off? It's because there was no water in the system. Going to show you some things that I am not fully conversant with here. You can probably explain more to me. There was an alarm going off there. Can you see it in the background? Let's go and have a little zoom in, see if we can see it. This is basement tank attenuation. Okay, so there's a attenuation tank. So we got rainwater and so on. I'm not fully familiar with this, but I'm going to try and get familiar with it, although it's not what I'm there for. So rainwater harvest, and then we've got these pumps here, these booster set pumps, and they are not happy. Two of them are in fault because of the lack of water in the system, so they've gone off. Let's have a look around here. There's two tanks. Okay, here we go. Irrigation tank runs all the way down there, and then the boilers are at the other side that you saw earlier. We've got valves. This valve is supposed to know when to open and close, but it doesn't. It has to be done manually at the moment. Then we walk around here, and then what we have here is the rainwater harvest tank. Second rainwater harvest, and then we walk down here. Fresh water explains where it is, and then we look up here. It's the top of the tank, and then that fills up. Can you see it over there on the left? That valve. So you open here, and then the valve will open up with water. At the moment that's happening manually rather than automatic. And then round here we have, what do we have here? Hydrovar. Not sure if this is supplying a swimming pool. This may be supplying a swimming pool. Checking the meters per second of air. So on these boilers, remember how to get them in high and low. It's quite easy. Ditch here you put on, and then you can change for how long you want them in high and low fire for. Okay, another site, and here is our cables, our supply and so on, our fan motor supply, and over here we have a gas-fired water heater on the right. They're both, this is actually connected into the gas-fired water heater as well, so there's two of them. They're sort of like a backup. It's always good to have backups in buildings. Never good to have one unit on. It's madness. So you have it there. It's just good common sense to have two and never one, especially if any building normally with a plant room is probably an important building where the services are critical. So this boiler is sort of like blocking. It's got a B code there, which means it's blocking. Something's holding it off externally. Beautiful display. And then this is the panel. So sometimes you've got to get them in to turn the pumps on, even though it's summer. Well, you could just about call it summer in the UK, but you have to sometimes force the boilers on for a moment. Gonna also remember, I was told the other day by someone not to show these secret ways of getting into the panel. But then again, I did think that people in plant rooms tend to be people that should be in there. competent people tend to be the ones that are put in plant rooms or have to sign all sorts of things in these kind of buildings. It's not like in your domestic property where anyone can get to a boiler. These boilers are not easy. They're almost like VIPs to get in front of. There's commercial engineers out there. You can see this is the enable. I'm going to flick it up for the unit because I need it's currently not on. So you could probably get to in front of celebrities more than you can some boilers. So I've heard of commercial engineers not being able to get any experience. So I believed anyways, nonetheless. So look, I'm checking. Got a switch live there. It's not easy to get in front of boilers. And if you're going to experiment or do things that are not safe, that's on your own back. I'm just showing these to people, hoping that you guys are competent and that you're not going to do anything silly in a plant room. Also, read the description of the disclaimer that I've got about being careful in plant rooms and safe isolation and so on. If I was a perfect engineer, or if there were a perfect engineer out there, you wouldn't have anybody on YouTube. So take what I do with a pinch of salt, please. If you're watching this, switch this on. Yes, I think that's the switch we needed to get it on. Check what's lighting up when we turn that on. Fan motor running. The gas supply to this is ever so tiny. You see it there going to the unit, very tiny. And you can see the controller there showing the sequence on the side. Here we have one here in action. You see the sequence. Here you can see the damper, or the amount of air, the percentage of air that's going in, the head pressure. Of my boiler when it's on, and you can see down there my sequence controller moving around in the red zone and then the green zone, and it's about to light next to our analyzer. So I was at the meter doing a gas rate. So when I did my gas rate on my boiler, this is what I got. Or should I say on my burner? So it isn't really, it's just for hot water. It isn't really, and there's two of them there, so it isn't really using up much kilowatt. Just check out the wiring in this plant room. So you can see it here. Pause when you need to. This is the upper page. Heating pumps, drawings, VT heating pumps, BSU heating pumps, hot water service pumps, more drawings, boiler 1, this is more relevant to us, boiler 2, boiler 3, and that's their connections. Boiler 3, Browag Kinta, Browag Kinta, Browag Kinta. Great, next page, to illustrate it more clearly, 230 coil they have written. Okay, VT valve, variable temperature valve. Another one here, inputs on the trend, outputs, lovely. We need to look at our digital inputs and our outputs. There's our DIX module. Okay, alright, more trend inputs and outputs. Pause and study this. Gas meter, water meter. Okay, what do we have here now? The panel again. Okay, what do we have here? Hot water service boiler 2. Okay, what else do we have here on this page? Hot water service boiler 2. More, and then VT valve, differential pressure control valve, excellent. And then here, more trend inputs and outputs. I think some of these are the same. Okay, so I'm going to stop here because I think some of these are the same drawings, but just doubles. Oh, now, here we go. The same panel we've been looking at. So up here we have our ROM DIM controllers. Okay, we have them here. I think these are like add-ons as well to help the DDC. Correct me if you think I'm wrong. And then here we have relays on the right. There we have our direct digital controller. Trend IQ, okay. We have our inputs and our outputs. Analog and digital. Alright, relays there. These relays can be bypassed to actuate, to enable certain things to come on. And then we have a breaker, more breakers here, loads of breakers, loads of MCBs. I won't see now, what is that? Are those just connectors there? Alright, and we've got on the left hand side over here, we've got contactors. Some of them look like three-phase, yeah, they look like three-phase, and then down here on the contactors before, wait, okay, down there looks like a transformer. 24 volts, 0 volts, okay, and then what do we have here? You can see the overload there, reset and overload. Can you see what they're set to, the different amps for them to trip at? Lovely. Okay, more wiring here and the numbers, and then there's our isolator. If you're still with me, much appreciated for watching the videos. I hope they've helped you more than they've helped me. Until next time, bye bye bye.